Hello, everyone, and welcome to today's One Key Idea session. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. This being a One Key Idea session, we're going to jump right in. Please remember that if you have any questions during the course of this webinar, you can submit them at any time. Please note they will be answered only at the end. So, today I want to talk about two key defect metrics. Lately I've been talking on LinkedIn and other social media about how it's really valuable and important to track your defects and or bugs if you prefer. And people are saying, well, gee, yeah, but not during the sprints because it's pretty much overhead and so forth. To which I say, if your defect tracking process is too much overhead, make it less overhead, but don't take away the things that add value from it. And I want to give you just an idea of two of the things that add a whole lot of value in terms of what you can get out of your defect metrics if you are wise enough to track them. So one of the really valuable things to track is bug backlog. Now, this is bug backlog, not product backlog. So I'm not talking about user stories that are in the backlog waiting to be worked on or anything like that out of the land of Agile. This is bug backlog, and it applies, applies to both Agile and traditional iterative life cycles and traditional sequential life cycles like a V model or waterfall. So it's a very useful metric, and it is a way of looking at how quickly or not quickly your development process, and this includes the entire development process, addresses bugs. So first off, just to define what this is, bug backlog on any given day is the total number of unresolved bugs that are sitting there waiting for someone to get to them. Now, by resolved, what I mean is either this has been closed, the bug has actually been fixed, and a confirmation test run, and the confirmation test passed, and we go, yep, that's fixed. Or it's been deferred to fix in the next release. Now, I'm not talking about the next iteration if you're doing Agile or some other iterative life cycle. I'm saying the next release. So it's like this is no longer an obstacle for releasing software. It can be accepted as a permanent limitation, or it could be canceled. It's a false positive or not actually a bug, works as designed, just various different names that are used for this, or it's a duplicate. Now, this is if you've got usable like severity ratings. When I say usable, I mean that people all assign severity the same way. So Sev1 actually means the same thing to everybody on the team. Sev2 means the same thing to everybody on the team, and so forth. We can look at severity by or backlog by severity. So you say, maybe the 1s and 2s are the high severity ones. You can say, we want those to get fixed pretty quickly. So we want to, we have a lower tolerance for backlog with those than we would say for the ones that, are less severe. So there are ways of looking at this metric, different ways of looking at this metric. You can do a tabular approach, but show it in a table, but look at backlog over like risk categories, major functional areas, those sort of things, product themes. Or if you want to show trends over time, you can do it graphically. Which is the example here is a trend over time. So this is a chart that some of you who've heard me talk over the years will have seen before. But basically, there are. Let me get the highlighter up here if I can figure out how to do that. Okay. Oh, there it is. Yeah. Spotlight. Okay. So there are two data sets, the red line and the green line, which are graphed against this axis over here on the right-hand side. And then there are three other data sets, including the average backlog, which are graphed against the axis on the left side, which you'll notice is 1/10 of the axis on the right side. So it has the effect of magnifying the numbers of the three data sets graphed against it, which are average reported, average resolved, and average backlog. So just to be clear, the total reported is the total number of defects that have been reported over time, and then the total resolved would be the number that are resolved per the definition that I gave before. And the backlog on any given day is the red line minus the green line. Now what we can do is we can show average reported and average resolved. So average reported is the minus here, and the average resolved is the plus on a weekly basis. So you add up the total number of defects reported, divide it by 7 for that week. That's the average daily reported. Same with resolved, except you look at closed. So the average backlog is to take the red line minus the green line on all 7 days of the week, total it, divide by 7, and that's what your backlog is. So what we see here is that there's a backlog trend that is going up. It has been going up since the beginning of test execution, and it is going up, and then it's actually going to drop there. It's starting to drop, though. Like any trend chart, it's not really possible to know what caused the drop or what caused the increase. You have to do further investigations to figure that out. But it gives us a sense of what our backlog is. And this is not filtered by severity or anything along those lines. So it might look different if it were to be filtered by severity. A closure period. Now this is another metric that's available to you. So the backlog was measuring just the total number of bugs that are in the backlog, and we had that trend over time. And so this is the number waiting to be fixed. Then the closure period is is somewhat different view. It's related information. It's looking at something that that is a similar thing, but different in a way. That this is the time required to close a bug. Okay, so the backlog is how many bugs are waiting for us to close, and it's sort of a you can see it. It's how big is the pile of work to be done, and then as you start to get through that work, what we do is we go through and see the backlog go down, and at that point, as a bug is closed out, we have the closure period is going to be calculated, and so the closure period is for any given bug. It's the date that the bug was open minus the date on which it was resolved. So it's basically the number of calendar days that the bug was sitting there in the backlog. Usually the way I'll do this is show it as a trend and show it as both daily and cumulative averages. Though here again, you can look at severity filtrations and groupings and so forth if you want. And you can do tabular displays, like what's the by risk category or risk severity. How long is it taking us to fix bugs? Now, one thing I will point out about this is that it is a lagging indicator, meaning that the backlog, if you have a large backlog, as you start to go through that and close out those bugs in the backlog, now each of those bugs is now going to have a calculable closure period because it will have a date on which it was resolved. Prior to being resolved, there is no closure period for the bug. It's not included in the calculation. Once it's closed, now the closure period is defined because you look at the number of calendar days that it was in the backlog. And so when you have a big backlog, the effect is typically going to be that you've got a lot of a big increase in the closure period over time until you get that backlog paid down. Basically, your technical debt is resolved. So just to show you an example of that, this is shows the average closure period daily and average cumulative closure period. And so the cumulative closure period here is the blue line, and then the dailies are the pluses. There are the green pluses. And the way that the closure period is calculated is for any given day, I can calculate the average daily closure period for that day by adding up the closure period for all the bugs that were closed on that day and dividing it by the number of bugs that were closed on that day. So for example, if I have one bug that was open for 4 days and another bug that was open for 8 days, now the average there is going to be 6 days. 4 plus 8 is 12, divided by 2 is 6. The average cumulative closure period calculates the closure period for all bugs closed on and before that date. Now, another way that people sometimes do this, which may be more meaningful for you, would be to actually calculate a rolling, like a 90-day rolling average or 30-day rolling average. You have to play with it and see what's going to be more meaningful for you. I've done this various ways for clients. This is just to kind of give you an example. Okay. And what you want to see is, well, kind of not what you're seeing here, just to be clear about it. What we see is that over time, the average daily closure period is trending up and is trending up fairly significantly over the last month. So if we did a 30-day rolling average here, what we'd be seeing is that there'd be a pretty steep spike, which you don't actually want that, right? Now, it should be kept in mind that your release process of how frequently you get test releases is going to influence and put a lower bound on this. So if you get releases, say, every day, you get a release every morning, then it's going to be difficult for the closure period to be less than a day, right? Even if bugs are fixed right away, there's some lag in terms of the confirmation testing. So there is a certain amount of process overhead that's associated with that you need to take into account. So those are the two metrics, and these guys, I've used these two metrics, backlog and closure period, to do all sorts of pretty detailed analysis for clients where I'm able to find literally millions of dollars in waste, because the longer a bug sits around, the more it's going to cost to deal with. We should remember that. That's a basic principle of testing, right? Is that as the bug gets older, the bug gets more expensive. It's pretty easy to if you've got these metrics, to come up with a rough estimate of the amount of waste that is associated with having a large number of bugs in the backlog and having a very lengthy closure period, and making a business case for the more rapid payoff of technical debt. So very useful metrics in terms of assessing the speed, the deliberateness with which your development process as a whole deals with bugs or defects. How good are we at keeping the quality up? Okay, so I'm going to go to the advertisement as usual here, and we will open this up for questions. I see we have some questions. So let's see what we've got. Amit asks what I think is a good question about the difference that I made earlier, the distinction I made earlier. I said that there's a difference between bug backlog and product backlog. He says, what is the difference between a bug backlog and product backlog? Once we identify a bug, it's no different than any other task. Well, yeah, okay. From a work point of view, Amit, I agree with you. It's outstanding work that needs to be done. That's absolutely true. The problem is that it is a product backlog item. If there's a product backlog item, typically, though not always, represents some new feature to be added. And I know that some people muddy the waters here by just putting deferred bugs that are deferred for the into subsequent iteration, not the next release, putting those into the product backlog. But that is confusing the situation, because one of those things, the bug, refers to actual technical debt, a form of technical debt, a known defect in the product. Whereas the other thing, properly, if it's a user story, refers to some incremental increase in product functionality. So it is valuable to differentiate those things, because we may be happy with our velocity overall with respect to getting stuff out of the backlog, but that doesn't necessarily mean that the defect management is going well. Michael asks, if a defect is deferred to a future release, not the next release, is it considered part of the backlog, or is it considered resolved? I would call that resolved. It's resolved for this release. We've made a deliberate decision. Now, you could, Michael, make the case that some bugs, when they get deferred like this, they are part of the technical debt, and therefore we need to look at them in some way or another. And I would agree with that. These two metrics that I'm talking about here are primarily about measuring our ability to make progress paying down technical debt in order to support the next release. If you want to have metrics that look at overall technical debt that has been accumulated, I think that's valuable. And certainly when stuff gets pushed into we'll fix this someday in the very distant future, yeah, that's technical debt. I would say that that's technical debt along the same lines as areas that have high levels of complexity in your code, or situations where there's tight coupling between pieces of code, or there are cohesion issues in code. It's basically, at that point, it's like, yeah, there's something wrong with the software that we're just saying we're going to punt on this. Let's see, I got a couple questions from Preeti here. Can you provide the formula you used for calculating average backlog? And he's also asking the formula for average daily and cumulative closure period. The source spreadsheets that are used to do those two graphs are posted out on the RBCS website, so you can go download those and see how they work. So now I will just caution you that the RBCS website on the template section is a little bit like a garage in a house where somebody's lived for a lot of years. There's a whole bunch of stuff in it, but it's not necessarily very organized. You get to have anything you want to download off of there for free, and other than using it to create competing intellectual properties like training materials and so forth, you can do anything you want with it internally. But because it's free, we do not provide any support for it. So if you want me to help you set up these metrics, I'm happy to do that. That's a service that we provide, and it would be a consulting engagement. Harvey says not all bugs get fixed, so deferred bugs should be marked and identified as such. Yeah, and I think you have to distinguish between deferred, for example, to the next iteration. Like, yeah, we're going to get to that, but we're not going to get to that this iteration just because of the volume of work. We're going to deliberately accumulate some technical debt, which we will pay down in the next iteration or in the next hardening sprint or stabilization iteration, whatever you call them, if you do those. And I realize that some people consider those things to be anathema, but we have clients that do them and they have so far not died and gone to hell because of it. So I don't think they're actually a sin. So yeah, there's the bugs that will be fixed before we release something. Then there's the bugs, Harvey, that won't get fixed in this release, but they'll get fixed in the next one. And then there are the bugs that are never going to get fixed. And I think there's some value in making a distinction on those. And as I said, the ones that we say this is a permanent limitation, we're never going to fix it. It is part of the accumulating pile of technical debt you need to be thoughtful about. Donald says, can you elaborate a little on the conditions that make it more expensive to fix a bug as its backlog time increases? Well, let me give you an example from one of my clients about why backlog can be toxic. And this is an example. We did an assessment for a client where they were following a variation of the rational unified process lifecycle, which basically is you have development of increment n+1 going on while testing of increment n is happening. So in other words, we're developing the next increment while we're testing the previous one. And the problem with that is that while that testing, which, these overlapping testing and development phases could be 2 or 3 months. While that testing was going on, the developers, since they were heads down writing new features, would never look at bugs, really, unless it was just a screaming showstopper that blocked all the testing. So what ended up happening was that the bug backlog would accumulate, and there would be tens of thousands. This was a large organization. And then when the developers got done and they popped out their next increment, they would then turn around and say to the testers, okay, we're ready to start looking at fixing bugs now. But because we've made so many changes to the code, we're going to need you to go through and check that all of those bugs in the backlog still exist. Now, you can imagine the amount of work that was associated with that. Some variation of that is always a possibility, even if the bug has not sat around for a couple months, even if it's just an iteration or two. It takes longer. The code has changed. It's a moving target. There's more work associated with figuring out what went wrong. This is one of the things that Agile is supposed to do for you, is to give the development team faster feedback on the quality of the work that it's doing. If you let bugs sit around, you're basically defeating that benefit. Let's see. Martin says, would there be a benefit to use a moving average or similar techniques to project future results? For example, cumulative open and cumulative close. Sure. There are all sorts of fun things you can do with these kinds of metrics, assuming that they're meaningful. You have to make sure that they're being gathered in a way that does, make the data valid. And this time does not allow going into full discussion of stuff that people do that makes metrics not valid, but I would refer you to my keynote speech, which is out on the RBCS YouTube channel. You can see the link to the YouTube channel right down there at the bottom of your page. There's a recorded keynote speech from the PNSQC conference from a couple years ago called "Stupid Metrics Tricks and How to Avoid Them." So I would just say, if you're going to use these kinds of metrics, you should go give a listen to that keynote and make sure that you're not making any of those mistakes, because that would undermine the value of the metrics. But assuming that you're not, then yes, being able to do various kinds of predictive things, looking at defect find and fix rates and so forth, and what is that telling us? This is a long established technique. William says, the older the bug, the more cost to fix. So if a bug is deferred to a later iteration, is that by definition raising its cost? I think on average it would be, yes, because when you go back and say, okay, now we're ready to look at this, the bug, um, the underlying defect is still there, most likely, because very rarely do bugs get fixed by magic, though developers sometimes suggest that they have. But the the failure that that bug causes may very well have evolved and changed. The way it shows itself as a symptom is different. And so now you got to go through and figure out, well, do the steps to reproduce the failure that were, associated with this bug report, do those still actually cause a failure? And what has changed in the way that that failure manifests itself? And you can have other things like somebody left. The programmer who wrote the code is no longer with the company, so now somebody's got to crawl through somebody else's code and figure out how it works. And so, there are various things that lead to the cost in general going up. Now, it is an average, and you're going to get a distribution around a mean here. So, it's not to say that all bugs always cost more when they're deferred. You're going to get some of these kind of black swan events where it doesn't. But yeah, as a general rule, and on average, yes, the cost will go up. Let's see, we got a question here from Amit. Going back to the difference between bugs and backlog items, where to draw the line? For example, security bugs are many times this feature is missing. Is it many bugs? Is it measuring bugs separately, encouraging the very useless debate of not a bug, it's a missing feature? If that's a dynamic that you see within your organization to meet, then I guess you have to deal with that. I think you could probably adopt some rules that allow the distinction to be made in a way that was meaningful. I would agree that there could be situations where the software fails in a particular way because there's code that really needed to be there. So, for example, you might not have code to do account lockouts when somebody's entered an invalid password for a valid login 3 times. Then you could say, well, yeah, that's a security problem, and the code should have been there. Have a rule for how you want to classify that kind of stuff. I totally agree that these debates of is it a bug, is it not a bug, is it a missing feature, that's not valuable. I find that people tend to engage in those debates more frequently when there's actually some sort of reward or punishment associated with that. If there's really no sort of psychological or financial reward or punishment associated with that distinction, then people will be, I think, more objective. Some people are contrary, though, so you can get people who like to have an argument just because they like to have arguments. Brian asks, many of our bugs are deferred by the program manager because they are deemed not regressions from the previous release, and it drives the test team crazy, so the backlog continues to grow. Okay, Brian, well, this session was for you, because this session has given you a way of measuring that and some ideas on how to slice and dice that in ways that illuminate why that's a problem. Now, remember, it's up to you to figure out how to communicate that to other people in ways that matter to them. If you say backlog is a problem because it drives the test team crazy, people are going to say things like, we all have pain in our lives, deal with it, or other similarly tender-hearted things that I've heard people say over the years. The trick is to figure out, how it hurts the program manager. So, for example, if developers are spending a lot of time and testers are spending a lot of time trying to figure out how to reproduce failures that are 4 or 5 iterations old, and there's a whole bunch of effort put into that, and so forth, so the debugging time is way higher than it would be. If you can do some sort of estimation of backlog leads to X% of reduced velocity because of lost development time trying to deal with the backlog bugs, then maybe that gets people's attention. But if you can't figure out a way of making your pain somebody else's pain, you're unlikely to get them to care much about it. Okay, well, great session. Thanks for the questions, guys. Hope you found it useful. Hope you enjoyed this free webinar from RBCS. We do these as a service to the software testing community because at RBCS we are a not just for profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We're happy to provide a quote for any such help you might need. Contact us at info@rbcs-us.com. One of the things that we do is help people with defect management and putting metrics programs in place. So if this kind of metrics look like something you would be interested in having and you need some help getting that set up, let us know and we will do that. This ends the webinar for the day. Thanks, and see you next time.